I'm Anil Kumar, and in this video, we'll take a few examples and understand direct and partial variation. The question which we are going to solve basically is identify initial value and constant of variation from the table. So that is main part which we'll do. We'll also try to figure out whether the values in the table represent direct variation or partial variation, right? So I'll make three tables for you. We'll understand these terms one by one with the help of the values in the given table, right? So I'll solve two, and the third one will be question for you to do, right? Let us consider that the independent variable is x and dependent is y. So I'll write down some values. Let's say for x we'll take values as 0, 1, 2, 3. Let me take values for y as 5 and then plus 4, 9, plus 4, 13, plus 4, 17, and so on. So that is one set of data for us. Another set, let me take this time the values as 0, 10, 20, and so on. And let me take this value as, let us say 100, right? 120. So let's increase by like this, right? And so on. So that is another set of values for us. And this is your test question, where what we are going to do is we'll give you kind of a tough question. Let's take the values as 0, 2, 4, 6. So we are increasing by 2 this time. And let the values be, let us say, we'll increase the values by, let us say 4, right? So we'll increase by 4. That will make us plus 2. Plus 4 is 6 and plus 4 is 10, kind of like this, right? So these are my values. Now the question for you is, from these, we'll number these questions also. Let's say this is question 1, this is question 2, and this one is question 3. Now you need to identify initial value and constant of variation in each case, correct? Now that is what you need to identify. Even before that, let us figure out whether it is direct or partial. Let's also see whether these variations are direct or they are partial, right? So let's try to answer that. So that's not difficult, but it's just kind of a review. So in this case, to check whether they are direct or partial, you have to check the value for x equals to 0. If y is non-zero, in that case, they become partial variation, right? So all of them are examples of partial variation. So all are not direct, they are all partial variation. So we found all are partial variation. So we have three cases for partial variations, and in these three cases, now let us try to find what is initial value. Now initial value is always a value when x is 0. So the initial value is 5. So that is 5. Here the initial value is 100, and in this case you know what it is, correct? Perfect. So let me write down. So we have initial value as equal to, in this case, 5, and in this case it is 100, and in this case it is minus 2. So we got the initial value. Now the question is, how will you find constant of variation? Now constant of variation is rate at which the numbers are increasing as we move by one digit in x, right? So that is the rate, increase in rate. Now how do you find that value? The best way to find that value is to use kind of a relation saying m is my rate of change or constant of variation, and it is always y2 minus y1 divided by x2 minus x1. Basically what we are trying to do is we'll find difference between these two numbers and divide by difference between these two. Now what is the difference between 9 and 5? So we can write this as 9 minus 5 divided by 1 minus 0. So that gives us 4 over 1, so that is 4 for us. So in this case, constant of variation is 4, initial value is 5. Now you can pause the video, answer the question for these two. we know the initial value is 100. What is the constant of variation? We are calling this constant of variation as m, right? Normally initial value is written by letter b, right? And we are talking about an equation which will be y equals to mx plus b, correct? So we know here b, the initial value is 100. And how about m? What is m? To find m, we'll do y2 minus y1, that is 120 minus 100 divided by 10 minus 0. 10 minus 0. So that gives us how much? That gives us 20 divided by 10, so that means 2. So constant of variation is 2, right? Now this is the test question. You should find constant of variation in this case. Okay, so we'll leave that for you. Now here, one more thing is, once we have found initial value and constant of variation, we can actually find the equation which represents the data. So let me add that term also, which is equation. Now equation that represents this data, that is how is y, the dependent variable, is dependent on x, the independent variable. So that is the part which we can do now. So knowing all this, that is not difficult. The format is y equals to mx plus b. So we'll write y equals to m, we found 2 as our slope, right, or rate of change, or constant of variation, x, the independent variable, plus b, which is 100. So it is plus 100. So that is how you get your relation. Now for this particular equation, I could write this as y equals to what? Slope is 4, so we'll write this as 4x, and y-intercept is 5 plus 5, the initial value, correct? Initial value sometimes is also referred to as y-intercept, so remember that part also. I hope all these things bring everything together, and now it should not be difficult for you to write down initial value and the constant of variation from the given data. So we'll have one more question for you to practice. Thank you and all the best.